All right, seems to be 11:30 now. So let's start. This is IPSECME meeting. I'm Tero Kivinen. I'm my co-chair. You are always in the online also. You can say hi.
Hello.
Yeah. All right, so this is the note 12. You have been seeing this already, and you can scan the QR code and read the actual text in there before. Uh, all right, and we have one more note taker. It would be better if people who could also help writing note minutes into the just questions and answers, especially people who make the questions or answers them. It actually, if they would actually go and check out that their questions and perhaps answers are properly recorded there, it would be very useful. Right. So we have very packed agenda. So we will see how far we should be able to get through everything, I hope, but we will see. All right. So we start with the working group status. So we actually published three new RFCs since the last time. So we have renaming the extended sequence numbers transfer type in the IC version 2, and we have a group key management using IC version 2, and then we have a mixed preset keys in IC intermediate and create child essay for of IC version 2. So, and we have nothing in the RFC editor queue anymore. We don't have anything in the publication requested, but that should be changing very soon. We have, I think we have at least two drafts should be going there, you know, after we get the separate write-ups and so on done. All right. So there is an PKC out and MLChem, and I think Scott is already written the one of the separate write-ups. I don't know, have we posted it yet or what's current status about that? We have three that are last call done, the downgrade prevention, and I think that's I will also go to the publication requested very soon. The diet ESP extension, they have been in last call or last call done state for a very long time. Hopefully we can get them forward at some point. They have been waiting all kind of other things going on and so on. So they're not really waiting for us. It's waiting for the other parts of the whether we actually there was some discussion on the transport area and so on. So and currently we don't have anything that is working group last call or actually even asked to be like in the working group last call now, or if there is, I don't actually remember. Uh, okay, comment from Terry. Tiru, go ahead.
Hey, good morning. The IQ to PQC auth draft has been in write-up for almost 4 months now. I was wondering if you could help accelerate that.
The PQC out, yes, that's in my list of to be done. After this meeting.
Thank you. Thank you so much.
All right. So we have lots of drafts that are in the working process. We have a hybrid chem stuff with accuracy to Frodo. We have an SATS payloads, which I think was waiting. One of the other drafts was the PFS info, if I remember correctly. We have reliable transport. We have a beat mode. We have ESP with version 2. We have ESP pings, which has been completely silent since the last IETF, if I remember correctly. We have PRF Plus and SAT3. And we haven't been seeing that much of discussion on in the mailing list. The ESP, they send an update just before the IETF. But of course, on the other on that, I would actually rather also have some implementation results before we actually get, because it's a big change, and I would actually hope to see some that they actually be able to get some benefits from it before we actually go and make a completely new ESP. But there's one more draft which is at the same time with the beat mode. Beat mode of ICE 2 is the negotiation IC, but there is also the actual ESP parts of that, which is going to be separate draft, and we are looking at that in the end if we have time. All right, so let's go to the presentation. So first one is the post-quantum, hybrid extended with ICE 2 with Frodochem. So I give you two slides. This one here, you should be able to use that too. One more. Okay, so I'm happy to take that presentation. Go closer to the mic. turn the mic. Make sure the mic is, you're talking to the mic. Is it on?
This way. Okay,
Yes.
it's okay. Perfect. Yeah. Okay, so I'm happy to give a presentation for Fredo in IKEV2. Yeah, so here's the basic information, what we're going to do for this one. So I will not repeat. Thanks for the group adoption. It's done by the beginning of February. So basically, we have received about 20 experts for the support from 20 experts, as I understand in the opposition. So a number of comments received, and we try to reply and revise our document as the 00 version for working group documents. So next, I will give this kind of the short summary, what we have done to respond to all of these comments. Okay, the first one is the running pure Fredo KEM. We explicitly say how we can do this one. So we add a new paragraph in section 1 to explain this. Next one is for PPK, post the content pre-shared key plus Fredo KEM. So can be also run this way as a one kind of the possibility for hybrid KEM. Yeah. So we also add a one small paragraph in section 5.2 for this reason. More consideration is about security. For security, we thanks for the experts, give our comments and a reminder. Maybe we can align the security discussion with the hybrid MLKM draft, which is going on the last call. Yeah, soon maybe I think. Yeah, so we discussed a few issues together with forward secrecy or forward security. Yeah, so we largely extend our security discussion in section 6. So a number of issues there. Like actually we mentioned, okay, about the ciphertext, about the randomness. Basically, it should be required randomness for different crypto procedures. There should be independent from each other. It's important. Yeah, it's mentioned here. It's very good for engineers themselves. Yeah. So we also mentioned, okay, how to prevent the downgrade attacks, because downgrade attack, the draft is already adopted as well. Next, about the recipient test. For this one, we checked both specification for ISO and also for IETF draft, Fredo algorithm, I mean. But we did not find any specific information about the recipient test. So currently, we just add a special subsection to mention this. Yeah, for it is this moment when we do not need to receive in the test for either ciphertext or the public key. But we are also aligning with the authors of the of the CFG draft authors to check if we should add any further information in future. So also have some question about the explanation of fragmentation. But this one we have discussion. I even have some proposed text. But finally, we decided to not input it now because we believe currently we actually explained this issue in our draft together with actually we cited the normative reference, both the 9242 and the 9370. So we hope it's enough. Yeah, so all of you are welcome to have a check our document and give your opinion as well. Yeah, last another one is about the title and the hybrid meaning, because in my understanding, the hybrid could be quite a general one. Yeah, if we specifically refer to a particular scheme, we will cite the document. Yeah, so in that case, another thing is about the title. Title actually currently suggests three of them. Yeah, but we still would like to keep the current one because the hybrid it is highlights the postal content, highlights the hybrid. Yeah, other two, yeah, may concede, but still I replied in the mailing list. Maybe not that good, but we still open to accept the suggestions. And the normative reference, we switched the ISO documents and the CFIG document as suggested. And slim down the background about the necessary to do PQ migration. So we did this one. Just the cut 3 original paragraph in our version 03. So we also did quite a number of editorial comments, for the whole document, especially some IETF keywords. We do not use it that right. Thanks a lot for the comments from Scott and Tom. Yeah, that's all. So in the appendix, we gave the detailed comments and our reply and action we have done. Yeah, most of our drafts I think we already addressed quite completely. Some I feel maybe need to a little further contention, attention. Yeah, that's all I think. Yeah, thanks. So we hope you get your further review, and if any issue we may have to address before considering, last working group call. Yeah, thanks.
Just Rokiven. So one of the things I think we should be aligning this and MLChem draft to be about the same, because they are actually about the same. They are defining how we put the post-quantum algorithm inside the key extension payload, and that's almost all that they actually need to do. They don't need to go to any of the background of the quantum analytic. They can mention that there's issues with fragmentation. There is we can use this as multiple key. You can actually use it at the initial exchange if you want. You can do whatever, but those are also always just it should be very short. We should be the most of the stuff to be just describe how to put it in there. And I would really like to have this to be aligned with the MLChem, that they would be about the same kind of thing.
Okay, thanks.
And that's also, I think that the draft name should be about the same. MLChem is just to saying we have this for IC version 2, and I think this should be just Frodochem in for IC version 2 or something like that. It doesn't need to mention any of the other things.
Okay, thank you. Yeah, Tim, please.
Yeah, I had a similar comment that both the MLChem and this draft have a lot of similarities with regard to fragmentation and various other issues. So it would be good to either add them in one document so that the other document refers them to avoid duplication. Uh, and the second comment was MLChem doesn't have any dependency, right? I mean, it's already a FIPS document, so I think they can progress, but this has a dependency on Fredochem and CFRG. I don't think it's adapted yet. So how do we plan to progress this, right? Are we going to push CFRG to adapt that, or like uh,
Yeah, about the reliable transportation or run actually pure for all. Yeah, so we have a new paragraph already. But for the dependence on the CFIG draft, we may consider later. Yeah, we will align with the author there. Yeah, thanks.
but I don't think we can publish. It's question back to the chairs. I thought my understanding was unless CFRG adapts this and progresses that to become an standard, right? This draft cannot be published, or we can go in parallel and publish this.
So I think we can also, we can have a informal references to the CRF draft that and that we can still publish it even if it's that is a draft. But if it's a normative reference, then we have to have a wait for that one. But also, I think the normative draft, I don't know how much of the normative reference is into the CFRT draft or is to the actual Frodochem specification, which I think is also published in some papers or something like that. This we can actually probably use as a reference also.
Currently, we still select the CFIG draft as the normative reference in our draft as suggest.
I think it's good for now, but I believe that's one of the things that if they CRFC are not going forward with the draft, then we might actually want to change the normative reference to be actually Frodochem.
On the other side, actually, ISO standard, I had a ISO standard for FreedoKM will be published soon, maybe in a few months. Yeah. Scott,
okay. I believe that because it depends so heavily on Frodochem, you cannot have an informational reference to that. It needs to be normative. If you probably point to the CFRG doc, you'll have to wait until the publication will have to wait until that's actually published. I don't know what the IETF view is on ISO docs.
Mm-hmm.
All right. So, but we talk about that. We just get that draft ready anyway now and through the last working group last one, that kind of thing. So you can actually solve the references issues later. Or Deb has some comments also.
Well, you have to solve the reference issues before you pass it to me, right?
Yeah,
That CFRG draft is unadopted. It's an individual draft in CFRG. They would have to adopt it and then have to progress it
Mm-hmm.
because you can't do it.
Mm-hmm.
Deb, I have something else to add as well, right? So what is happening in the LAMPS working group is the FredoChem drafts were proposed for both certificates and CMS messages, and then the chair said that they won't adapt it till the CFRG adapts the FredoChem document, right? So I think probably some guidance from the AD would be helpful for all the working groups which are working on these kind of non-NIST standardized PQC algorithms.
So the charters are different between IPSECME and LAMPS. LAMPS clearly says in its charter that it has to be either a NIST specification or a CFRG specification. IPSEC doesn't say that in its charter, so it's a little more open. On the other hand, FertoChem, you have to find a reference to FertoChem that's not either paywalled or unfinished, right? Because you need a normative reference to FertoChem that's stable and not behind a paywall.
But anyway, I think let's bring that back to the list because we are running out of the time anyway. Unless you have a very short comment on
Maybe the chair should talk to the CFRG chairs.
I can do that. I actually think it probably could be wider discussion about that. All right. So
we talk to the CFRG chairs pretty often. We have not done it this time. I can add this to the list of things to talk to them about if you want me to.
okay, so this was still. All right. So the next one is Valerie. Came out in IC version 2.
Hello, can you hear me? Can you hear me now? Okay, this is a draft that was presented in the last ITF. It was published in new version. So first, a few words about motivation. So usually with post-quantum crypto, at least for MLChem data is much smaller than MLDSA. MLChem also demonstrate better performance. So it is a good reason to introduce CAM-based authentication because there was a long history of such work starting from MQV, HMQV, and IQV1 we also have had public encryption authentication mode. There are also a couple of works, individual draft in TLS that deal with CAM-based authentication. So this draft tries to introduce CAM-based authentication for IQ2. So the outline is the peer perform first ephemeral hybrid key exchange, and then also exchange the long-term CAM public keys, public certificates, certifying the CAM public keys, and peer perform two exchanges with using these certificates, and then prove that they know sharded secret generated from this ephemeral key exchange and stirred with these long-term key exchanges from certificates. So in IQ2, we try to reuse the existing feature that we already have. So the ephemeral key exchange can be based on RFC 9380, multiple key exchanges. So we also can reuse hash and URL for retrieving large certificates if they reside somewhere outside and are publicly available. So we also use ICO's exchange for confirming authentication. So it's all existing feature. and we also rely on downgrade prevention because it's highly recommended for protection against downgrades. And so what's new and 0.3 version? So we were pointed out by some riggers that the current draft doesn't protect initiator and responder identities against active attacks at all, because certificates were exchanged before any operation on them are performed, using them are performed. So the active attacker can see both of them and know identity for both parties. So it's generally not possible to protect both identities against active attacker, because one of the peers should reveal its identity first, but it's possible to protect at least one identity. So this draft was changed to add this feature, and it requires some redesign of the protocol. So for this reason, we added a new payload. It's called encrypted certificate payload, eCert, and a new certificate encoding that is just X509 bundle. X509 bundle was defined in RFC 7296, but it was only used for hash and URL bundle. But now it can be used inside IQ2. Oh, it's a little time. So the exchange. So first, IKSA need. Then we perform IK intermediate confirming, proceeding with hybrid key exchange, and perhaps with some other purposes. For example, post-quantum key exchange as defined in RFC 9867. Then we perform IK intermediate that is concerned with the out-SCAM protocol itself. How it is called? So first, responder sends its certificate first, and then initiator sends its certificates encrypted using the key that is produced as using responder certificate, so that only responder can decrypt initiator certificate. So in this case, we provide protection against active attacker. So, and ICOs just complete the authentication. So session key are computed as in previous draft, no change here. We slightly change the notification, so we get written out-SCAM data, instead introduce out-SCAM ciphertext and out-SCAM SSCONs. Role SSCON was explained before, so just to save time, I will not repeat its role. So it is needed to protect against misconfiguration when, for some reason, private and public key are not corresponding to each other. Since we immediately steer shared key into the session key for ICOs, in this case of misconfiguration, we will get garbage while decrypting. So aus payload, it was explained before, announcement method is from previous configurations, it encrypted certificate payload. So it just resembles an encrypted payload, but instead of another IK payloads, it's certificates content of one or several certificates that are formed in the X509 bundle. So we need to have only one encrypted certificate payload. It's easy to encrypt one payload instead of several payloads. That's the reason to introduce it. So it's a bundle encoding taken from IQ to RFC. Security properties, I will not repeat it. So it's very interesting about protocol optimization. So currently, we need to have two additional IQ intermediate exchanges for out-SCAM. And the idea is that we can get rid one of these additional exchanges with some complication of the protocol. And so what is the idea? The idea is that we send responder set certificate in the set payload in previous IK intermediate exchange. In this case, it will not be protected with session key generated from ephemeral intermediate exchange, ephemeral hybrid key exchange. It is not good. So we can complicate it a little bit more. So we can still send this certificate, responded certificate, in new ESET payload and encrypt it with the key that will be generated for the next exchange. It is still possible for respondent, it already knows this keys. It just don't use it yet. So in this case, we will have all the security properties from the base protocol, but we will remove one intermediate key exchange. So only one additional round trip for CAM-based authentication. So I think it's doable, but the question is whether it is worth to, it's a little bit complicated, but still doable. So I believe I'm a little bit over. So comments and perhaps consider adoption.
Yeah, I think we probably to check it out in the list, and you know, I think the working group should be able to adopt this document. I think it's I think I don't see any reason for not, and I don't see anybody coming up and say we shouldn't be. And of course, they can bring it up in the adoption call. All right. And you have, I think you have a next presentation also.
Yes.
Just go forward and it's the next slides.
It's me. Okay, sorry.
No.
Okay, to call for adoption, I would ask questions whether or not the gain and the performance gains would be sufficient to justify the additional complexity that this adds. My opinion is it doesn't look like it, but I think that's something that the working group would need to consider.
Yes, it should be evaluated. But I also want to point out that there are slightly different security properties that can be very attractive for somebody. For example, in this protocol, it is responder who reveals his identity first instead of initiator. So it protects initiator privacy. And another interesting security property is complete repudiation. So both parties can regenerate all the transcripts, so nobody can prove, or the third party, that communication have taken place. So it's slightly different. Perhaps it is attractive for somebody besides of performance. So thank you. So use of ALK fragmentation for large messages. So what is large? Well, when ALK fragmentation was being developed, we thought that 3 kilobytes messages are large messages because they caused IP fragmentation. IP fragmentation was developed for messages of that size, and we believe that it handles them very well. So perhaps 20 or 30 or 60 kilobytes are large messages, like some post-quantum signatures, like SLH signatures, for example. Well, those signatures are still feed into the IP payload. We have more fragments, but we still hope that IP fragmentation will handle them. But what if we think about several hundred kilobytes? We all know one CAM that has a public key of this size. And first of all, we need new format for IP payload, and we have a good candidate. And I just want to request chairs to issue an adoption call for this draft, because I raised a hand when you spoke about status, but I was missed. So it just take time to, because I have an implementation and we have an application for this big payload. So if you issue adoption call, it will be very good. So, but coming back to fragmentation, the number of fragments will be very large for UDP, and so is it really doable? So just I did some experiments. Because we have these 7 additional key exchanges transforms, we can actually configure up to 8 key exchange method in total. And I just created this Christmas tree. So I did a lot of different CAMs and taken the largest possible variants of them. So you can see it's in total, all these CAMs must be performed in order to to create a single essay. So, and I have two desktop connecting via 1 gigabit network, and sometimes I switch it to 100 megabit just to see if there is a difference. So it's data. First, using TCP. Using TCP, it works. Implementation is still needed because of the for classic macOS. But it takes about 20 seconds or something a little bit more to create an IQSA with all these messages. It doesn't matter whether it is 1 gigabit or 2 gigabit. Then I switch it to UDP. It works, but you can see that the number of really transferred fragments is much higher than the number of fragmented the message is fragmented to, especially for macOS with big sizes. So the message is fragmented into 3,000 fragments, but because of fragmentation is not efficient, we in reality we send 8,000 fragments because of the transmission. Because each time we resend the whole message with all the fragments. So if the number of fragments is few, it's not a problem. But for large number of fragments, it's just very inefficient because network has been filled with garbage traffic, and a receiver need to process all these fragments and discard them. It takes this power, congestion, and what solution can be? What can we propose? Actually, we can add some status receipt notifications that can be sent from receiver to the sender, indicating which fragments it has already received, so that these fragments are not transmitted. And this idea was thought when fragmentation was developed, but at the time for the few fragments it was considered too complex. But now for the larger number of fragments, perhaps it makes sense. So actually there are two proposals, one from Anthony, a second from me. Anthony, Stephen, and Tobias, and the second from me. And so overview is very simple. Just receiver a fragmented message sends status report to the sender. Sorry, if not all fragments are received, and sender just transmits only those fragments that are not received. So if I compare the proposals, the devil, not the devil, but the difference in the details. So in my proposal, I use a specially crafted fragment message, and Anthony's proposal use notification payload inside a non-fragmented message, and I use a bitmap, and Anthony use a list of fragment number, and so on. So in my proposal is not negotiated, and is negotiated, and that's details. So just to check, I created a proof of concept implementation and repeated my experiments. So you can see that the number of recent fragments is in blue is several times smaller than when this extension is not used. So it is not STCP. TCP, of course, is more effective. But if you, for some reason, do not want to use TCP or cannot use TCP, but still need to send fragmented messages with substantial number of fragments, this extension can help. So it's very easy to implement. It took me perhaps one day or a couple of days to implement it in existing implementation. So any comments? First question, is it needed? And if it is needed, perhaps it should be adopted.
Anthony?
Thanks to Valerie for summarizing both of the proposals. And the technical details are very minute, but I would like the working group feedback on both of them so that we can get the best of the two. Thank you.
All right, then Johan Hoop.
Next. Oh, I can see.
Yeah, who you here? So one comment that I think, like you said, right? So one straightforward solution would be just using TCP. I know somebody doesn't want to use TCP because using TCP also means that you TCP for the ESP. But if we could have a mechanism that separate the IKE and ESP, for example, IKE using TCP, ESP stay as UDP, then I think that problem should be solved in most cases.
That's true, and I agree with you. But I've heard that some people cannot afford TCP for the implementation for some reasons that even for RIKE, because they may have some proprietary operation system with very constrained devices that just don't implement TCP at all. So
I guess at least from my point of view, majority of our problems don't have this issue. So I mean that would be much straightforward way to follow.
Anthony, again, like I don't think that is true, because the TCP and UDP creates two problems. One is if you have a NAT, you need to open two connections, one to TCP go through the NAT, and one to UDP to go through the NAT. That's an overhead. And also, if you do it in the hardware, you have to maintain the TCP socket as well as UDP socket, which is also double the overhead. And that's one reason we are pushing for a UDP-based solution.
All right. So I think that's everything we had for that. Let's continue that discussion on the list and then go to the next one. Who's the next one is Thiru.
it's me.
Oh, it's you are doing okay.
It's me again.
All right. Just continue then.
This presentation is about using hybrid CAM in IQ2, a composite hybrid CAM. So currently, what we have currently, large CAMs cannot fit an IKSA need. So we use IKE intermediate for this, and we developed multiple key exchange in RFC 9370 to be able to fit all the shared secret, to steer all the shared secret that were calculated in all additional key exchanges into the session keys. And we believe this is secure, and that everything is okay, except that it takes additional round trips. And despite that we believe that it is secure, the mainstream of cryptography thinks that combining CAMs with traditional elliptic curve shared secrets should be done where especially designed combiners that were, well, the cryptography put a lot of efforts to invent a proper way to combine these things. So TLS is using this combiner, and so most of cryptographers think that's the right way to combine traditional and post-quantum key exchange is to do composite hybrid key exchange. I don't see most cryptographers, but at least it is used in TLS, and TLS, well, is mainstream for now. So can we use composite hybrid key exchange in IQ2? So this draft defines how to use it. So first of all, we now have a separate transport draft that allow IQ2 to run over TCP, and ESP still run over IP or over UDP. So this raises the problem that with the big payloads, with the large payloads in the IKSA need, and so we can just put a larger payload into the IKSA need if IKE is run over TCP with no problems. And actually, if there is a closed environment with no IP fragmentation problem, you can run IKE over UDP2. But we consider still separate transport as a main more general idea for this solution. So a combined payload containing both public keys is placed into IKSA need, and in response contains both shared secrets that are concatenated. And so we calculate shared secrets using universal key combiner, and that's all. So SKCT is performed as defined in RFC 7296, but using combined shared secret as shared secret. Which algorithms are considered? It's COVE 256 MLCAM 768, ECP 384 MLCAM 124, and COVE 25519 MLCAM 768. This is a draft, reference to a draft. So any comments?
Hi, here is Guiling from Huawei International. So we'll go to slide 3. I think it's slide 3, called the untested constructions. Yeah, this one. I don't understand what does it mean, untested hybrid constructions.
Well, it means that the way how we do in RFC 9370 is not approved by formal analysis of cryptographers, because they put all the effort cryptographers put into hybrid CAMs was to invent a combiner for composite hybrid CAMs, and not for non-composite. For non-composite, we believe it is secure. We think it is secure, but we don't have vetted analysis from cryptography community because they just didn't look at it.
Okay. I see. I roughly understand. Yeah, maybe we can communicate later. My second comment is that from my understanding is that you are trying to solve the same question, yeah, as the previous one, yeah, by different approach, right? This one basically proposed to use TCP transportation. The other one actually try to do is solve the same problem, but it's just in IKEV2 itself.
Yes.
So I suggest that you actually looking both of the draft together and considering which one maybe select or maybe decided both.
Well,
I would like to review the drafts. Yeah, thanks.
Previous presentation was a generic presentation how to transform larger payloads using only UDP. But this is not strictly related to this, because if we put large payload into IKSA needs, now if fragmentation takes place, fragmentation is only available starting after IKSA need. For IKSA need, we only have to use either TCP from the very beginning, or we have to be sure that no IP fragmentation problem in the network. For example, we have closed network, closed environment, and we do know there are no firewalls, nets, and so on. IP fragmentation works very well. So in this case, we can put a larger payload into IKSA need. But previous presentation was concerned with IP fragmentation. IP fragmentation is not available in the IKSA need.
Okay, yeah, thanks.
So, Hujun here. So I haven't read the draft yet, but I assume that this draft reduced the round trips, right?
Yes.
Okay.
It eliminates IK intermediate.
Oh, that's good. I think that's very useful. I mean, for us, like product, we offer the simpler implementation, simpler idea, because with all this PQC introduction, I mean, the protocol exchange become longer and longer and bigger and bigger. I'm all for the simpler, smaller. Yeah, thank you.
Hello, am I unmuted?
Yes, you can
okay.
see the green face.
Scott Fleur Systems. Because we already have a existing solution which addresses this, I'm wondering the need for yet another solution which covers essentially the same material with the extra limitation that it has to go through TCP. Although the complexity isn't very much, it's just basically defining another KE payload. I'm still wondering, is it worth the effort to fragment the community to have two different ways of stressing the same problem? Thank you.
All right, I think that's let's go to the next presentation then, because now we are getting a little bit delay. That's not you anymore.
It's not me.
All right. So I think I had, who had Marco? There was a Tiger Xu. So you can use the clicker here. No remote presenter at all yet.
Okay. Hello, everyone. I'm Xiaohu from China Mobile Cloud. I'm newcomer to IPSEC working group. Although this draft is almost 10 years old. The reason that I want to refresh the draft is I believe this draft is still very useful in today's use cases. The first use case is use IPsec for SD-WAN scenarios. Currently, many cloud providers allow IPsec user to use multiple parallel IPsec tunnels to improve the total bandwidth between the customer side and the cloud side. Besides, some cloud providers also use IPsec tunnels to secure the traffic traversing their data center interconnection one for security and compliance purpose. To further utilize the bandwidth over the WAN and the internet, it's better to leverage UDP tunnels to transport IPsec traffic. Encapsulation IPsec ESP over UDP is very simpler. It has same logic as other UDP tunneling technologies such as VXLAN. Another useful scenario for IPsec ESP over UDP is many IPsec gateways are implemented in the form of multi-core x86 servers. In that case, to improve the performance, the RSS module will use hash function to distribute the received packets over multiple CPU cores. In this case, if we can implement IPsec ESP over UDP with UDP source port as HLP field, then we can make better load balancing over multiple CPU cores. As I mentioned before, the encapsulation scheme almost is the same with other UDP-based encapsulations, such as VXLAN, MPS UDP, Lisp, and some others. Here, the source port is used as HLP field, which is used to indicate a given floor. If two IPsec gateways are encapsulating multiple flows over a single tunnel, then they can use source port to distinguish different flows over that given tunnel. Currently, there are multiple implementations about this technology. One example is Junos, which has implemented on its router product. The co-authors believe this draft is ready for a working group adoption call. That's all. Any comments or suggestions are welcome.
Valerie?
Valery Speslov. So I read the draft and I have some questions. First of all, it's not clear for me why do you need to allocate a new port. So from my understanding, all the functionalities that you define are already available in the IPsec, because actually if you use UDP encapsulation IPsec, source port is not needed at all. It is thrown away. You can put it into any value. The only problem is that if NOT is detected, and usually UDP encapsulation is active with NOT is detected. So the peer that is not behind the NOT should update its destination port based on the packets, authenticated packet received from a new port. But this can be disabled very easily if you make, for example, if you use Mobike that doesn't implement these features, it's forbidden for Mobike. Or for example, if you forced...
Can you speak slowly?
If I speak slowly, I will not, it's a counter, a red counter. I have only 1 minute left.
Okay.
So actually, I will speak slowly. Actually, from my understanding, you can get all this functionality from the current IPsec protocol. First of all, you need to force UDP encapsulation. It's easy. You just put a garbage or some fixed value into the NOT destination, not detection destination IP, and your peer will think that it is behind NOT. Because it is behind NOT, it will not update its source port. And then you can put any value into the source port of your ESP packets, because they're not, source port is not used for processing of incoming UDP encapsulating ESP packets. So I believe that everything is there already. So I'm not clear what new would you want, and especially do you want a new port allocated for this reason?
Okay, as I mentioned before, although currently cloud provider suggest user to use multiple tunnels to improve load balancing.
Yes.
But it will consume multiple public addresses, which is expensive, right?
Yes.
Especially when the traffic volume become larger in the AI scenario, they will transport very large volume traffic. And this traffic is security sensitive. IPsec would be used in this case. That's why I think it's time to refresh this draft. If the volume is very slow, maybe just 2 tunnel is good enough.
But you just do load balancing.
Yeah.
But load balancing you can do just randomizing source port, not the destination port.
Yeah.
Okay. All right, but anyway, so we are running out of time, so let's take to the list.
Okay.
And yeah, so yep.
Okay, thank you.
So the next one is you need to go forward there a couple of slides.
Okay. Hello, everyone. This is Jimmy from China Mobile, and I would like to introduce the draft multipath secret sharing for QKD key relay in IP networks. So let me share the motivation first. And the security of the QKD network is guaranteed by the quantum mechanism and does not dependent on computation complexity. So I'm sorry, I'm a little short-sighted and I can't see the screen. But in the long-distance QKD network, due to the physical distance limitation, it is necessary to rely on intermediate trusted relay nodes to forward keys. At these nodes, the key exists in plain text, and the key will decrypted from quantum state to electronic signal and re-encrypted to quantum states that negotiated with the next hop. And so because of this, the relay nodes become the potential exposure points. And so this causes challenges. And this because the long distance QKD network security model is an all or nothing security model. So as long as any relay nodes on the path is compromised, whether physical or logical, the entire end-to-end key will be completely leaked. As the network scale expands, the probability of node compromise increase significantly. So we propose a solution that called multi-path secret sharing. This draft proposed the solution aimed to transform the security model from single point trust to threshold security in the QKD network. So SR-V6 multipath planning is combined with secret splitting to mitigate the trust node problem. And so as you can see, here is a QKD network architecture logically, and the quantum layer, the quantum layer and the key management layer are responsible for random number seed, generate random number seed and transmit it. And the routing layer, which is the solution be deployed, is responsible for the network path management, and the application layer is connected with the traditional network through IPSEC or IPv2. So this solution has 4 parts. The part 1 is key splitting. So we can use a threshold secret sharing scheme, for example, Charmy secret sharing, split the generated random number seed. And the part of multiple transmission, the origin key can only be recovered at least T share are collected. And path isolation is using SR-V6 technology enforce that the N share are transmitted over in physical disjoint paths to ensure no common relay nodes. And finally, we can recover the key at the destination node. And I think that is a whole solution. Next
I
step
think
is,
we have to take a questions to the list because we have 3 minutes and we have still
Okay.
one more presentation which is supposed to be given 5 minutes. So
And
bring the
what-
questions to the list.
Okay. And one question. I'm not sure the draft solution is within or without this scope of this working
Yeah, I
group
think
charter.
people need to read the draft and be able to say my question is not
Yeah.
necessary. So but anyway, so
Yeah, thank you.
let's go to the final presentation. And no, we don't have time for Anthony.
Okay, I shall be faster. Okay. Okay, so I would like to present our new draft called the multi-authentication in IKEv2. This is the 00 version. So the first, we give some a little bit of history or current work in IKEv2 authentication. Basically, the main idea is to use supported auth message notification type from the RFC 9593. So currently 2 drafts there. Yeah, one is actually use MLDSA and SLHDSA or any PQ signature for pure PQ signature authentication. Yeah, second draft is from June called the composite signature authentication. But this one actually it is special specify about the certificates. It could be dual certificates or actually composite certificates specified by labs currently. Yeah, and for this draft, we would like to actually specify a flexible multiple authentication. The basic idea is that, okay, 2 peers are able to negotiate multiple authentication methods, yeah, in IKEv2 authentication. And these multiple methods not necessarily symmetric. Yeah, different directions have different sets of methods to authenticate. One more thing is, of course, these methods not necessarily belong to the same category. Could be different combination. Here is some example. Could be a MAC plus PQC signature, or maybe traditional signature and a PQ signature, or maybe PSK and a PQ signature, or even more. So what we can do is one is that our basic idea is just to mimic the means of negotiation ADDKE for K exchange. So we would like to provide a flexible choice between the two peers. So basic idea is the first guy, like A, can send a number of set of authentication message to the other to the other peer B, and B can select one authentication message from each of the set and give the answer. But of course, this way can be done from B to A as well. Yeah, so this just specify how we can do this by extending the authentication message announcement specified by IPSECME 9593. So here example, actually we try to actually give some compact answers so that it can save some communication payload. Yeah, so here we give three kind of answers. The answer have particular meaning. The first case, if actually here we have something like 10 or 12 algorithms, yeah, like A can actually separate the 10 algorithms in three sets. Just ask B to select one of algorithm for authentication. Yeah, select one from each set. Yeah, so like this one, B just reply, okay, A1, A4, and A7. So these three algorithms will be used for authentication for both direction, from A to B and from B to A for authentication. And the second case, still select algorithm in these three category. Yeah, but actually the authentication message from A to B and from B to A are different. Yeah, and the last one is for general case. If B cannot select algorithm for A, yeah, in that case, B will say, give the general query to A, as A just did before. Yeah. So next one is just how we can do this by use the notification and type specify the previous RFC. So in the first line, yeah, we have what is particular authentication code for multi-authentication. Then we will specify, okay, in this notification, how many authentication message group we are giving together with the, okay, for the first of the set, how many authentication messages announced in this payload. Yeah, then just like concrete detail about the first authentication message and the second authentication method, etc. Yeah, a little bit complex, but the basic idea is simple. Here is just an example how we can do run the protocol procedures. I think that's all. Yeah, appreciate your comments and the review. Yeah, thanks.
All right, so this was the last presentation. I think we have to take all the lists because we are minus 2 minutes now.
Okay.
And one of the things where you should, somebody was sending a email to the list asking for comment, you should actually mention how this differs from the, the multiple authentication exchanges we already have.
Oh yeah, yeah. Oh yeah, I dropped the omission in this one. Okay.
All right. Okay. So we don't have any time for any other business. We did ask for 1.5 hours for this week, but we only get 1 hour, so that's why we are a little bit cutting short. But we are, have to do with what we get.
This will be easier going forward, right? Because we don't have to deconflict with Paul's working groups anymore.
Excuse me? I couldn't.
This will be easier to schedule going forward because we don't have to deconflict between Paul's working groups and my working groups.
Yeah, that's true. That's true. Paul is always the well blame, I understand.
Exactly.